Okay.
Dude, cheers.
Cheers.
Fuck yeah, man.
Okay. Thank you, Dr. Luke Stella. He is a doctor. The first real doctor I've had on the show.
Oh, wow.
I want to get, firstly, actually, I want to ask you, have you ever heard of nominative determinism?
I actually have. Yeah.
In reference to your specific name?
A little bit, yeah, and it kind of really pisses me off, honestly.
So we're off to a good start.
Yeah. No. A few really just like kind of smart uni lecturers who thought they just like knew everything will pull out these big words.
Yeah.
Nominative determinism, like, you know what's going on.
Yeah. So for context, I think I may as well explain.
Yeah, of course.
It is sort of when someone's name matches what they do with their life to some degree. So, because I was thinking that like in the olden days, that's how it started. Like you had Harry Baker and he was Harry the Baker of the village.
Yeah.
But now like last names are cemented. And so it's more rare you find someone whose last name is what they do. So yours is Stella.
Yeah.
Spelled with an E at the end. Different.
Different. Yeah. It's actually, when people try and get real smart about the nominative determinism stuff. So it's Stella but with an ER, and it's as far as I can tell, it's a German name, and it was derived from like Schneider, which means to like cut, I think.
Okay.
And it's like what like people would do, they'd trap like mice or like little rabbits, and they would cut their fur as like a fur trapper. So it really, like, I feel like my, ancestors were like catching rabbits and like turning them to hats or something, So I feel that's the real nominative determinism going on.
We'll start somewhere.
Yeah.
Okay, perfect. I just wanted to get that out the way because
of course,
Luke is an astrobiologist. Is that what you describe yourself as?
Yeah.
And so, but really like your main strong point from what I've read is understanding the origins of life on Earth, specifically through the idea that life came up in a hot spring.
Yeah.
Now, before I want to get to this, but I actually have a hard, tricky question I want to ask you first.
Yeah.
Okay. My question to you is, what even is life?
Yeah. That's a real, I think that's the big problem in astrobiology, So like astrobiology, it's astro, space, biology, life. So it's really like what is the potential of studying, what is the potential of finding life elsewhere in the universe?
Like what are you even looking for?
Yeah, well, that's what are you looking for, And I think that a whole bunch of folks at NASA got together and came up with a definition that the hard thing with definitions, as soon as you put anything in a box, there's all these exceptions, right? So they came up with basically it was a self-replicating chemical system that can undergo Darwinian evolution.
Yeah.
So it's kind of like what they said. So it's like, all life on Earth fits into that box, right? We're all chemical systems that one way or another we can replicate, and then we can undergo Darwinian evolution, as soon as you put that in a box, there's all these, issues. And a lot of people, if a organism is, infertile, say like they can't have kids, or like if, I had this amazing, professor that I met in the States, and she, had just gone through menopause, and she's like, I cannot reproduce anymore. Am I still life? Like the definition, she was really sticking it to them, because as soon as you put something in a box, there's always going to be exceptions to the rule, know? Yeah.
Especially like when we kind of have our sample size of biology is one, right? Sort of astrobiology. So, we have no idea what, it could look like. And so I guess this leads to another question I have, and something I often think about is if we were to find, hypothetically, of course, and I think we'll deal with a few hypotheticals because I quite like speculating.
The whole field is hypotheticals.
Of course. Perfect.
Same state.
So hypothetically, if we found multicellular life on another planet, would you presume it would be surprisingly or somewhat similar to life on Earth, or would it be so different we couldn't fathom? And I have a fact that I think has always sort of guided my intuition about this, is about the eyeball has independently evolved, and I don't know the exact number, but I think it's around some people think 60 times. It's between like 40 to 60 times, I think. And so what that sort of tells us is that like every species that has eyeballs didn't come from a common ancestor. It's sort of, at least how I interpret it, is that like if you're going to live, you kind of need a set of eyes. And so if we went to another planet and found complex life, surely they'd have eyeballs too, and two of them.
Yeah.
So that makes me think like maybe life in the universe would be maybe quite similar to life on Earth.
Yeah, it's a really again, like it's all hypotheticals, right? But it's an interesting question. There's also this phenomena in biology where things end up evolving to look like crabs. Have you heard this as well?
I have. I always get the YouTube video on my like feed. Yeah. I haven't watched it yet.
Yeah. I basically just know it from that thumbnail as well.
The thumbnail.
Yeah. But it's this concept that like there's all these same as the eyeball, like there seems to be like the structure and the shape of a crab seems to be a very good tool to survive and to pass on your, have kids and to pass on your genetic offspring. So evolution converges and drives a lot of, species to end up looking like crabs. The interesting thing is with the eyeball analogy, like, yes, like the idea of an eyeball evolved, over 60 times in all these different species. But at the same time, if you were a doctor or an eyeball surgeon and someone put even like a sheep's eye or a cow eye or something that was evolutionarily very similar to a human eye, they could instantly tell you that's not a human eye, right?
Yeah.
Like there's still nuances. There's still like very, very real differences between these kind of, these different systems that you can find in biology. So I feel that if you found life on another planet, we don't know if all life even needs cells. The idea of a cell and like a sort of a replicating building block that builds up life is something that makes a lot of sense, but like it may not be like that at all, or we might find a cell, but then you look inside and it's totally different, or it could be really similar, but the DNA has got a different kind of structure. I feel like there would be, the chance of something looking identical to life on Earth that we have here is very rare, And another cool thing to think about as well with the eyeball thing is that we all had really the same selective like pressures, even though you had, like something like a squid and a sheep and a human all have, two eyes that are, at the front of it, whatever a head is or whatever it looks like. We all evolved in a planet that had, light and, light and visible range coming in. We all had predators that would hunt, roughly in a certain way. We had the same general Earth-based environmental, parameters that, you could say maybe that's what made us look the way we did.
Yeah.
Where on, Mars may be similar, but if you found life, say, on Venus, like the conditions on Venus are so different to anything that you could find on Earth,
Yeah.
You would expect life there to, evolve very differently.
And I guess like another issue is that this is sort of at the macroscopic scale. We're talking about what life looks like, but at that microscopic level, even like smaller than the cellular level, like the actual chemistry that life runs off, could that be fundamentally different on another planet? So I know like we're carbon-based life, and I heard you talk about like theoretically maybe there could be silicone-based life, right? Or could there maybe even be a possibility that there is another liquid other than water that life could use? So are these things you would explore in your field?
Yeah, I think that like the field of astrobiology definitely explores all that stuff, right? And even in our solar system, I know like Enceladus and Titan and then these moons around Saturn and Jupiter that have just like crazy conditions. Like there's like it's so cold that methane and other gases like condense and form liquids, and there can literally be like lakes of methane on these ice sheets in these, moons circling different planets. So with that in mind, like there could be some weird biology that doesn't use water but uses methane as a liquid methane as the solvent or as the like, soup that it moves around in. So yeah, there's definitely ideas like that. Silicon life, I think, always really excites people as well, But from my understanding, like life, as you said, like, eyes keep popping up all over evolutionary history, there's a few things that make sense in our biology. And for example, like having long strings of atoms like linked up together makes a lot of sense. So like DNA, you know, like having long strings together, that works really well for holding information. Because, you know, if you're trying to write a piece of code or write a message or anything like that, the sequence that your letters or your numbers are in is super important. Because without that, it's just like an alphabet soup, just all floating around. So you need to be able to string things together so you can read back to front or left to right or whatever way it is, you know, and that's what DNA does, you know, it's like four letters, four really simple chemicals, but because they can string them, they can make this amazing complexity because you can read them in a very specific order. And if you want to have long strings, or like chemists call them polymers, like long strings of molecules all strung together, certain molecules are a lot better at doing that. And like carbon's great at that, you know? And water's great at being a solvent to hold long molecules like that.
Yeah.
Where silicon, a lot harder to do that, you know? It's a lot more rigid, and you can't have these strong variations in the sort of structure. And as well, you need to have different temperatures, different pressures to make it liquid and move around. So yeah, I feel like carbon life with strings of molecules like probably pops up a lot in the universe if there was life out there. But again, yeah, it could be something super whack as well, you know?
Yeah, so and of course, to re-emphasize, it's all highly speculative. But yeah. I get, like, what I'm picking up is that it could be possible, we don't know, but it appears like it makes the most sense.
Yeah,
If water was involved, if it was carbon-based and it sort of built these long chains of molecules, which is kind of like what we are at our most fundamental.
Yeah, that's what everything is that's living on Earth, really. And again, like, it could be super weird somewhere else, but in the field of astrobiology, it's a really interesting field because it's not like the discipline isn't built around a phenomena, right? Like geology is like, we're going to study anything that has something to do with rocks, you know, and that's a very clear thing. Or chemistry, like we study chemistry, we study molecules and atoms until they start forming systems that start moving around and living. And then we hand it over to the biochemists and the biologists, you know?
Yeah.
And physicists, they're like, we're going to study the forces in between molecules and atoms and the things that build up atoms. But as soon as they get too big and too complicated, we just hand it on to the chemists, you know? Like there's set rules around based on the phenomena. When astrobiology, it's based around the question, is there life out there?
Yeah.
And because of that, like you have, you know, philosophers, you have chemists, biologists, you even have like ethicists and lawyers, of all these different people thinking about this problem. And you're really just trying to, you know, create a more probable answer. Until we find it, we'll never know. So yeah, it really is just like, we have no idea what's out there, but it's more likely to be made out of water, more likely to be made out of carbon, more likely to exist between 0 and 100 degrees Celsius. Like you can kind of put it in a bit of a box.
I guess that's sort of like what's always drawn me to astrobiology, because it's definitely a field of science that I've always been really fascinated in. Yeah. And I think what draws me to it is what you kind of said is you know, the philosophers are drawn to it. It's philosophical in nature. And so and why I sort of open with that question of like, what is life, is I know that that's a question that also philosophers as scientists try and answer. And so what would you think of a sort of simple definition that life appears to be the only thing in the universe that like kind of, it has intent. It sort of, it does something for a purpose. So like a rock kind of just exists, right? It just does. Everything, right? Like, you know, even the ocean or the air itself, they kind of just exist. But we can point at life and say like, it exists, but it's trying because it wants to survive and it wants to reproduce. And so it's a very open-end question, but definition, but I've always been drawn to it because it seems to me like it opens up the definition. So it's very unscientific. I'll admit that it's very unscientific, but it opens up the definition so much that to me, like that's what the essence of life is about. It's something that has this kind of purpose to its existence, is that it's not just there, it's there for, maybe I'm not explaining myself well.
No, it makes sense. And I feel like when you think about us, right, it feels like our whole life is either driven by purpose or this anguish of trying to find our purpose. Like we have a very philosophical, moral view on life, and if you watch even like animals, or plants, like, oh, that plant wants to grow towards the sun, it's driven by this kind of purpose. But it starts getting really fuzzy when you are looking at like the simplest forms of life and you look at like the chemical systems that make them up,
Yeah.
And some of the work that like collaborators that I would work with were looking at was like, you look at even like a cell that's, like a sperm swimming towards an egg. And you're like, that's a cell, that's quite a simple chemical system. Crazy amount of intent, it's really working towards something. But then like there are chemical systems that are striving for equilibrium, as well. And that's what all life really is, it's just a bunch of molecules that are trying to balance out a chemical reaction, and it's trying to shift hydrogen one way to the other. It's trying to put nitrogen back the other way because that will create a chemical balance. And that's what chemical reactions try to do. And you just stack up enough of those and then you have your sperm swimming towards your egg, So it's like a really blurry line. It's like, where can you say like a chemical system doesn't have intent?
Yeah.
But then you have enough of them all clumped in together and then you start seeing intent out of it. Like how do you differentiate that?
Yeah. Yeah. Well, I've kind of always, another like topic I always find interesting is like emergent properties. So when something at sort of the most fundamental level, or just say the deeper you go, it doesn't exist. Its existence sort of comes out of, just say, when you put a bunch of them together or when a bunch of things interact. So like an example, for example, is like a sponge. Like a sponge is spongy, but when you zoom in, there's no part of nothing of like the physical solid that it's made of is spongy.
Yeah.
That is an emergent property of the greater whole. And so life appears to be similar in that like the atoms we are made out of are not living, but you kind of put them all together and they're alive. So it's like, at what point in that scale do we be like, that's where life begins?
Yeah.
And so to me, like, where's always like, and I know like biology sees this as the big gray zone is what they call like non-cellular life, or like viruses, for example.
Yeah.
So I've heard them be described, viruses, as biological entities, but not living. But then there's sort of a part of me and that just be like, oh, yeah, it's not alive. It doesn't fit all this sort of criteria that we put. But there's something about a virus that makes me want to give it like a bit more credit. Yeah, like, what, like, there's something special going on with them. I know they're simple. They can't reproduce on their own. They don't have a metabolism, right? Or, a variety of all these other things.
But you could look at a virus and like, it feels like there's intent there, like it's got a mission of reproducing, it can't do it on its own, but it wants to, infect the host cell and get in there and spread its, genetic material around and then get that to then replicate itself and keep going. But there are heaps of like animals you would say are very much alive that are parasitic and need other things to reproduce, like, I'm pretty sure leeches, or mosquitoes, they need blood from other animals to reproduce.
Yeah.
And very similar to a virus, they actually can't self-reproduce. They rely on other, biological systems to help them reproduce. But you would say that they're very much alive, like a mosquito is not a gray zone for biologists, and I think it's because viruses are so simple and they don't have a metabolism really. And when you look at them, you can start breaking it down as a complex stack of chemical reactions. But it's not as complex as cells. It's kind of like in that, in-between zone. And it's easy to be like, oh, maybe that's not it. But if you try and pin down any of the reasons why that is, you can find faults in all of them and other things that we call very much alive. So yeah, again, like it's people have spent, whole careers and decades thinking about, what is life? And I don't think we're going to get to the bottom of it. And if we find other life out there, you know, it's just going to be like an N of two. You know, of two examples.
Yeah.
It'll still be all these gray zones and weird things going on.
Yeah. So I guess the big question then, are we alone? Is there life out there? And I guess I understand. This is more of a personal question to Luke rather than a professional question to Dr. Stella.
Yeah. I think, like, and this is a little bit of Dr. Stella sort of coming in there. I feel like life as it's, you know, defined by NASA's definition or whatever, like a slimy microbial mat or a sponge or like something very simple, like statistically it has to pop up places, you know? Like I think that the chance that there's slimy microbial mats growing on Mars, like very cool if we find them, obviously incredible, but like it's not going to surprise anyone, you know? Like, oh, like, that's really cool. Like, did that come from Earth? Did that form there on its own? Like, that's, you know, a really, really interesting and amazing question. But to me, like, that's not the juicy part of it. I think the juicy part that, like, Luke gets into it is the life that particularly, like, humans are is so crazy. Like, we've over-evolved, like, intellectually on nearly every level. Like, there's no... like from a very baseline level, there's no genetic advantage to be able to do quantum physics, right? You know, like it is very likely not a chance you're going to have like more kids if you're, you know, really good at algebra, or can make podcasts, you know, like there's all these things that we do that you know, you can link into like interesting ways of thinking about, you know, higher primates and like apes had very complex social systems. So the ability to like map out a complex system, like, oh, like you're dating her, but I'm really in love with her as well. So I'm going to get this person to come and beat you up and then I can sneak in, like that level of like mentally mapping out complex systems and modeling them. Like that helped us at one point evolutionary, you know, I think there's quite a lot of argument for that. But the fact that we didn't stay at that, you know, monkeys, you know, fighting in a complex like system,
doing our thing,
you know, like the fact that we've come on to like be able to create art and to stress about the meaning of life and to, you know, like think about our space in the universe, like that is like there's no reason why we have to do that as life. And I think that's kind of unique. Like I think if we ever find aliens in like the Star Trek, Star Wars kind of sphere where we can chat with them and we're like, whoa, like what's the existence of life like to you? Like to me, that seems very impossible.
Yeah.
Not impossible, but like getting there. And if you do, that would really blow my mind. That'd be the cool shit, right?
Yeah. And I guess like the problem with that is not only like the unlikelihood of sort of hyper intelligent life existing, but then even if they exist in our galaxy, to communicate with them is probably just as unlikely.
Dude,
like the fact that, you know, light, the fastest thing in the universe, is so slow compared to like honestly, how big the universe is. It is pathetic. It's like a snail, and you just, you know, like our closest star, it would still take 4.5 years just to send a message. 9 years to get one, you know, like you've been waiting 9 years to get a response.
Dude, like it's been left on red forever, you know? Like it's just like it'll be the slowest, most drawn out conversation we would ever be part of, is trying to interconnect. And it's interesting, I've had chats with people working in this field, but also, you know, thinking about there's this, you know, physical cap on communication, which is the speed of light, right? You know, which, as you said, like is a snail's place in the galaxy. Like people who claim to, you know, explore ideas of telepathy and that kind of stuff, like this telepathy, if it does exist, does that happen at the speed of light? Are there ways that, you know, I don't believe personally in telepathy, I haven't seen that kind of stuff, but it really is this question, like how can we, are there any ways around this, you know, universal constant of the speed of light when we are, you know, thinking about intergalactic like either in our galaxy or even between galaxy communication, like wormholes, you know, ways to bend time space. Like there's we really have to think outside the box, because otherwise we're stuck in a very, very slow conversation, right?
Well, I mean, my guess would be like a wormhole would be realistic, like the most realistic option, despite the fact it's very unrealistic of those things, you know. Totally. And we don't know if it's possible. It could cause like a paradox to destroy the universe. But like, I guess, you know, that's just like how it is. But I find it interesting that, like, you know, I feel this, and I'm sure a lot of people feel the same. It's like we don't want to be alone. There's something about, you know, you can think about this on like a personal level of like, if you're suffering from some condition, right? Like it's always better to know there are other people out there in the same boat as you, and you share an experience. In fact, it's not even like through suffering, even like a happy moment. Like you need to tell people about it. It in a way, like sharing an experience makes it valid, makes it real, and on a large scale, like us humans, like while we can talk about this with each other, philosophy, we can't compare notes with people who have, while cultures are different to some degree, like in the grand scheme of things, like it would be great to compare notes with an alien civilization and just be like, you know, did you guys kind of come to a conclusion about God? And they might be like, no way, like, no,
why would we?
No, isn't it obvious? Like, whatever. Like, so to me, like, I guess that's kind of why, like, you know, is that feeling of being alone is scary, right? Like,
But I think that, as much as I agree, you know, it'd be amazing to have conversations like this with someone from a totally alien, you know, culture. Because at the end of the day, like, all of our, like, humans, like, very different, you know, across the world, and we're all kind of the same, right? We've all got the same, you know, like, neurological wiring. We all have roughly the same emotions. We all have roughly, you know, like, the idea of, like, God or a higher power pops up in every culture, really. Even cultures that, you know, again, it's this convergent evolution, right? Cultures that were separated for hundreds of thousands of years, you know, still had ideas about high powers and, you know, supernatural forces coming in and
music as well.
Music, you know, and like love and
facial expressions. You've just brought up a little thing I love, like, not to interrupt, but I find it really interesting, like what is common about humans cross-culturally, because it sort of says something about like who we are genetically, like what is sort of written in our DNA. So things like existentialism and curiosity and music, art, these are all like, these aren't cultural inventions, despite how cultural they may seem. They're like truly written in us to be like that. Which I'm always amazing. Like, I know. I always like think that's so cool, because we do like to sort of figure out ways of dividing ourselves. But these kind of feel like the crux of like what it means to be human, and like we all share it.
And I think in a weird way, like that would be the most interesting thing to see if we met other intelligent life in the universe. Do they have all of that stuff? You know, and kind of like eyes in, you know, how it's popped up in all these different species, like, is like music or like art or culture or like love, is that a common element that is needed, or, you know, at least very, very highly selective, a selective benefit for creating intelligent life, you know? And I think that's what, like the book Sapiens, I feel, I read it ages ago, but that was the kind of gist of it, right? Is that the reason that humans evolved the way we did was because we could tell complex stories about things that don't exist. Right? You know, in the way that we can, actually.
Do you want?
Yeah, go on.
So keep going. This is a good topic.
Yeah. But, you know, it's like this idea that like we can like create a story like money, you know, like money doesn't exist. Money is the most made up thing in the entire world. Yet we found this way to tell a story about this like imaginary token that somehow drives all of our, you know, interactions and has built, you know, a global economy around this thing that doesn't exist, you know? So a lot of people would say that like the idea of telling a story that something doesn't exist between humans, and sharing that story and sharing a belief in that story is actually a strong evolutionary benefit that we've actually used, you know?
Yeah.
And interesting, you know, like when you think about intelligent life on other planets, like, would they have that? Would there even be individuals? You know, like, would there be individual entities, or would it be one, you know, continuous, you know, like entity that's evolving, but isn't split up the way that we're split up, you know? Like,
Well, I think there is almost an evolutionary benefit to, well, as you said, like the storytelling, but specifically what I think it is that through like being powerful storytellers and story receivers, we, I don't want to be too speculative, but almost like transcend our DNA. And what I mean by that is there's a number, it's got a name, sort of made by this anthropologist, but it's the theorized number that like pre-modern civilization or society, like human societies maxed out at. And so it's something about 150. And when I kind of think about it in my own life, I'm like, I feel like I have a relationship with 150 people. It sounds like a lot of people, but you know, you really think about it, and what you know, I'm not putting my like definition of a relationship as something very intense. I can see why it can't go beyond that. And essentially and we see this with other primates as well, they cap out in their little tribes or communities at a certain number before social instability grows, and then they split. And humans have this number, but our storytelling is so powerful that it transcends it, right?
Right, yeah.
And I also think about it in terms of, you know, like, just say myself, like as a young man, maybe I would have to engage in some form of like warfare or fighting or hunting. But, you know, like culture appears to change us and shape us more than what our hormones and DNA do. Maybe not more, but to a degree. Anyway, I'm sort of rambling. But the point I'm trying to say is that, like, of course, this is what makes us so powerful. But it's specifically, I think about like the fact that we can kind of rebel against our genes, and so we're not slowed down by our genetics. The rules that govern our behavior are no longer sort of 4-bit you know, nucleotide bases. It's an alphabet of language that we write in books and talk to each other, and that is, you know, maybe not infinitely, but or close to infinitely more complex, and therefore, but obviously, so many problems come to that.
But it's such an interesting thing because, like, I've heard this, you know, anthropologists talk about that idea of like over 150 people without a shared narrative. Like, you just start getting that like tribalism, us and them, right? You know, like, you know, roughly, like, you know, 150 people well, you're like, yes, I can relate to that person, even if they're different, like, we're on the same team, you know, like, you can get that. Any more than that, you start getting factions forming, right? And it's like us and them, and very quickly, that's when people can separate out, and then you get warfare, you got being like, they're a threat to us, and then it all falls apart, you know? But then we, you know, as, you know, humans and Homo sapiens, like, develop this way of, like, we kind of hacked that process, right? We've overcome that issue because we can have a shared narrative that can tie together, you know, 8 billion people on this planet. And the interesting thing is that, like, would that stretch to other species?
Well,
or other forms of life? Like, if we find another, you know, alien life out there in the universe, are we going to be able to be like, hey, like, we're both intelligent, you know, self-conscious, like conscious of our own, like ability, self-aware, hopefully not all self-conscious, but probably are as well.
A little,
but you know, like, like we can share this narrative together, like, this brings us together, or we're going to be like, nah, they're way too alien for us, like, there's no common ground, and we're going to be able to overcome that. And I think that'll be the real challenge for, you know, your idea that like, story can overcome DNA. That would be the real test of it, right?
Like, this is sort of why I brought it up originally, is because my intuition tells me that another advanced civilization must have this sort of degree of storytelling because it offers that degree of growth far beyond your own DNA. But at the same time, I've also just thought of like a counter argument to that is like what's called, this is part of it, is like the great filters like hypothesis is like, our intelligent civilization's doomed to fail. And so while our storytelling ability has, turned us from mid-tier, somewhere in the middle of like a food chain to the top of the food chain in, ecologically a very short amount of time, it also brings so many problems to us as well that could be the death of us, And so maybe some other advanced civilization just totally comprehends the world around them in such an unknown way to us that is more stable on larger groups.
Totally. And I think that and without giving too much away, but there's like the free body problem. Have you like read that book or watched the series?
As in like the problem with three objects orbiting.
Yeah. Yes, it's like free objects orbiting, but it's a name of like a sci-fi series, which is like really, really interesting.
I think I've heard of it.
Yeah, it's so cool. And like I'm gonna butcher this, but basically it was written in by a Chinese author, and it kind of starts off around like the Cultural Revolution in China, and about this idea of like narratives are great, but also like they murdered tons of people that they thought were different to them, right? They murdered professors and people who they thought were, they spun a narrative to be like, no, like these people aren't us. We should exclude them from our society. And that's happened in every culture, everywhere around the world, right? And it starts, that's how this book starts. It's an incredible book. They're really exploring kind of the hard edges of this kind of idea that narratives bring us together, but without giving too much away, and like there's an alien species in the series, but they're incapable of like lying. Like the way that they communicate and I won't, get into the details of it, but the way that they communicate means that like deception isn't really possible the way that we can do it, right? Like I can lie to your face right now, and if I'm good at it, you'll have no idea. But if we communicated with chemical flashes, or if you could see my neurons firing right now, if my skull was, transparent and you could see what's going on, I could tell you one thing. You're like, no, I know exactly what you're thinking. Like you can't do that. And that's a massive benefit to us, but also like that's our limitation. Like that's why we end up killing everyone. Really, like we have this mass, like warfare and huge, unrest on this planet because we can lie to people, we can manipulate them, and like there could be other species out there in the universe that can't do that. Would that help them survive a potential great filter event or not? Which is a cool theory. I feel like it's a really interesting concept. And just for from my understanding, to recap it, it's that like from the way I think the story went was that they had this thing called how did it go? Because there was a Fermi paradox.
Sorry, this sun is like right in my eye.
You want to
anyway.
like shift around?
No, this is good now. I'm just going to wear the sunnies for a bit. Sorry, keep going. Okay. I didn't mean to interrupt.
Like the story, I'm mind blanking, but you can, jump in later and it'll come to us. But basically, like in the 60s and 70s, a bunch of scientists got together, and this was like the very like early days of astrobiology, like real like the beginning of it. And they were just like, the Drake equation. So there's this thing called the Drake equation. A bunch of scientists got together and were like, what is the possibility of life being out there in the universe, right? And it was this super crazy bunch of people. Like it was this guy, I'm going to forget his name. It was basically like a dolphin intelligence expert. So someone that studied non-human intelligence.
Wow.
And we're thinking about that. There were astrophysicists. There was like a young Carl Sagan who was like in their like early to mid-20s, just like in this room of people in like a, like, they're like, let's just all like catch up and chat about this like equation of like how likely is it to be life out there. So they, were like, how many stars are there in the galaxy or in the universe? Like I'd say the starting number, you can like model it, you can kind of figure it out. What's the chance that those stars have planets around them? You know, like how many planets are per star? Then from that, how many of those stars have planets that may have life? So they may have conditions that are suitable for life, you know, like do they have water? Do they have a habitable zone? Like all that kind of stuff. And you kind of work your way down to like the chance that a planet that could have life on it, like Earth, that life actually formed, you know, and that's a huge number. Like the chance of it forming is 1 in a million or 1 in a billion or whatever it is. But because you're starting with such a huge number of the number of stars in the universe, even though you're kind of whittling away, by the time you get to the end of it, there's still like the chance of their life being in the universe is massive, you know?
Yeah.
And even intelligence life. So then you kind of come to the question, it's like, well, like, where is it all? Why does the universe feel so empty when statistically, probability-wise, there should be so much life out there? And that's where this Fermi paradox comes in, you know? Like Enrico Fermi was a physicist, scientist, and they were just like, yeah, like maybe there's like things that are, you know, like stopping that life from forming, including that great filter, which is like there's probably an event somewhere in the evolution of life that stops life from getting further, you know? And that could be like, maybe it's very common to have, you know, single cellular life. Like it might be very common to have your, you know, microbial mats and sponges growing everywhere. But then from that to get to multicellular life and start making, you know, lizards and snakes and dinosaurs and things like that, maybe that's a really hard jump. Yeah. And that's your great filter event.
Right.
You know?
So that counts as a great filter too.
Yeah, yeah.
Right.
So it's like, you know, like, so, and that's the question is the filter, is it behind us? You know, like have we surpassed the filter event and now we're in this like beautiful, you know, like the, you know, look into the horizon, the sky's our limit, we've kind of got far, or is ahead of us, you know, like
I think most people would say like it's not sort of plain sailing from here.
Yeah,
right?
yeah, totally. Yeah.
This is what I wanted to like as well mention is like what it seems like is with every superpower there's a super villain. That's a bit of like a anyway, what I sort of mean by that is like anything that gives us like the potential for like greatness and a lot of power. So whether it's our storytelling or our incredible ability to like conceptually think or whatever, right? Is it also comes with a negative use to it. Yeah. And I've always thought science is somewhat similar in that every sort of discovery opens a door. Science is a tool that can be used for creation or destruction. Yeah. And so like a classic example is, and what is relevant to the great filters is nuclear energy. Yeah. Is like the potential good nuclear energy can do for the world is immense, but the potential bad it can do for the world is as immense, if not, you know, worse, right? And so I just always think that's like an interesting like area of science and why, slight side point, but you know, people think science should be like what's the word, amoral, like not immoral but amoral, sort of not, and like apolitical or whatever. But it's like, well, at the end of the day, science is actually very concerned with how we behave and how we act because it's so powerful. Like you can't totally just do it willy-nilly.
And then I think that you know, science, or like the idea of, you know, science or inquiry, on one hand it is amoral or like impartial, right? You know, you can be like, hey, here are the
impartial, that's
you know, you could be like, okay, like this is what's needed for a advanced civilization to succeed, you know, and this is what's going to kill it. Like you can impartially do, you know, hypotheses and models and experiments and figure that one out. As a human doing science, being an intelligent species, once you figure out like, oh, like this is what's going to either, you know, end us or not, it's impossible really for us to not act on that, you know? Or if you're like, okay, like I'm going to do impartial science on creating nuclear weapons. You know, like we're just going to try and create like a, you know, a cascading, you know, nuclear reaction, whatever that is impartial science. Humans doing science, I think it's impossible for us to not see that and be like, whoa, like we can use this to either generate incredible amounts of energy or, you know, create a nuclear winter and destroy the Earth. You know, and I think that I think the process of science is impartial, but humans are inherently biased and partial. I don't know if that's a word, but you know, like we're inherently are biased, and we can't do science without bringing our politics and our shit into it, right?
Yeah.
You know, and I think that's one of the great limitations and beauty of humanity, you know, because I think we then act on it for better as well. You know, we're like, okay, impartial science, there are species that go extinct due to certain events, you know, like you can say, yeah, that's like good science, whatever. Humans doing science are like, well, like the thing that's making this species extinct is directly caused by our actions. I don't want that to happen. I'm going to act on that, you know?
Yeah. Yeah. It's sort of like gives you an insight, like an unbiased insight, but at times you can't help but like...
Totally.
You're like, well, you know, as the moral bias, you know, biological organism I have with desires, like I interpret this data and say like, you know, we should do this, right? And I guess if enough intelligent people come to the same conclusion, then it's like, well, you know, maybe we should listen to the scientists, right? Yeah.
Totally, yeah. But it's interesting, like, I think that studying geology and the Earth's history, right, you learn a lot about, like, these mass extinction events, you know, and, like, when life was, you know, like, getting going and complex life was forming, like, 4 or 5 times in the Earth's history, there's been events that's just, like, wiped out, like, you know, 90% of life.
Yeah.
Like, you know, the meteorite that destroyed the dinosaurs is a really famous one, but there's also been like huge ice ages and huge, you know, volcanic eruptions and all this kind of stuff that just like kills 90% of life of species on Earth, you know? And you kind of like take all this diversity of, you know, life and you shrink it down to a bottleneck of like, oh, looks like you're just going to have some like really weird feathered lizards survive and then a few little tiny marsupials, and from that, like rats that live in caves, and from that, oh, let's create a whole nother evolutionary era where humans are going to evolve out of that, you know? And I think that you can view that as being like, well, like we are so insignificant. If we wipe out, you know, ourselves and take a few, you know, a couple hundred species with us, like life will go on. The planet like will keep going. Like a nuclear apocalypse will just warm up the surface of the Earth by a couple of degrees realistically. And then like it'll keep going. Life will evolve on. Yeah. But like we don't want that. We don't want to be responsible for that. You know, like to preserve ourselves, but also like, as you said before, there's a inherent intent to live in all life, you know, like wanting to self-replicate is it's a characteristic you see in a lot of all complex life and nearly all life on Earth, you know, like, oh, like that plant wants to grow towards the sun, that cell wants to find nutrients and survive. And I think that as a entity that also does that, we can say, no, like that's something that we want to preserve. We don't want life to go out, you know? And I think that's something that makes us uniquely human and uniquely alive. And I think that that's something that should be celebrated, you know, this intent not to fuck up the world. You know? Like, I think that's really special.
Yeah, definitely. And I've always thought what makes us like quite remarkable, and I'm a big fan of humans. As bad stuff as we do, I actually think we are fucking beautiful and amazing. And that is one aspect I'm always impressed by, is like our capacity of empathy towards things that don't have a direct, possibly indirect, but not a direct impact on our own survival.
Massive.
And I'm always so impressed by that, because I mean, I did sort of evolutionary ecology at university, and you've done a lot in this field as well, right? And at first glance, it doesn't seem like, you know, it's like, why should I care for a tiger, right? Or the life of a tiger, or, you know, even little things like I get upset if I step on a snail, right? And no like biological part of me can make sense of that. But then this sort of aspect of humans that I think is so remarkable is like we care for that. You know, it's, I mean, I guess a question to you is like, how do you reconcile that within an evolutionary framework?
Yeah. Again, I feel like, and I think this is a really beautiful thing that we're very lucky with, that along with our runaway intellect, you know, like, as I said, like we're kind of, evolution drove our intellect really beyond the point that was necessary. You know, we didn't need to evolve the ability to do complex quantum physics, you know, but we did. Like, we just ended up being these species that can do it. In the same way, I think evolution drove our empathy and our compassion to a point that you don't see really in any other species. You know, like the fact that we can look at a snail, which is so genetically isolated from us, you know, and like killing that snail has no impact on our ability to pass on offspring, which really should be the only evolution. If you kind of like boil down evolutionary biology to like, we are driven by Darwinian evolution and our ability to pass on, you know, viable offspring, like that doesn't mean anything to us, that snail. But you still, like, if you're walking down the street and you could step on a snail or avoid it, you would choose to avoid it. And I feel like most humans would, you know? And I think that that's a really beautiful thing.
Yeah.
And I think that's really, if we had that, you know, incredible runaway evolutionary process of, you know, developing our intellect without that empathy, I think the world would be a really messed up place, you know? And I think that would be our great filter event. I think if we didn't have this empathy, we would have wiped ourselves out a lot quicker than we have now.
Yeah, probably already, right? Like,
massively, yeah. And it's easy to look at the world and see all the, you know, bad stuff and all of the suffering and all of the suffering that humans do to others. And you can be like, you know, humans are shit. And we are, you know, a lot of the time. So like pretty bad. But like, from a, you know, evolutionary biology and evolutionary psychology perspective, there's nothing that requires us to not be shit, but we choose to, you know, and great people in this world choose to not be bad people and to be good people at the sake of their own lives sometimes. And that's really special. And I think that's like a really, when you talk about, you know, coming back to astrobiology and looking for life in the universe, like, that's something that I really admire about humanity. And I think that's something that I wonder if we found other intelligent life in the universe and we chat to it, like, is that the same elsewhere, you know? And I think that's something that would be really cool to talk about. But like, yeah, I think we're really special in that way. Yeah. As, you know, as a collective on Earth.
Yeah. I mean, I agree. Yeah, it is definitely, in my mind, what really sets us apart.
Yeah.
This makes me want to ask, because I should have said at the beginning, but you're not just an astrobiologist, you're a science communicator too.
Yeah.
And that now is more of what you do with your time, right?
Yeah.
And so, I mean, what drove you to do that? And it is kind of what we've talked about, like the beauty of humans. Is that tied in with it?
Yeah, I think so. Honestly, and speaking candidly, I think it's what, like, it was like my own drive and my own, like, just like enjoyment, right? You know, I think, so for context, I was doing a PhD in astrobiology and I was replicating chemical processes that could have led to the origin of life in a lab. So it was really cool science, and I was in this lab and we're trying to literally, like, how do you make RNA and how do you make DNA and how could that DNA hold useful information, and like really exciting cutting edge science. But to do exciting cutting edge science, you have to spend 50, 60 hours a week cleaning test tubes and mixing up experiments and processing data, which I could do, you know, and like that's part of the process and part of the science. But I didn't enjoy it. I think what I enjoyed was getting together with other scientists and being like, oh, like, what are you doing and how do we collaborate and what are you working on? And then also I love just like going to the pub after work and just, you know, chatting with people, like, you know, like, what the fuck's out there? Like, what is life?
What the fuck is going on?
What's going on? And I think,
why does anything exist at all?
Yeah. And I think that's like, for a lot of your listeners, and I know for yourself, like, that's where I would spark up and that's where I would get excited. And that's where I would feel this real, like, wow, like the world is weird and beautiful. And like, I can't chat to aliens about it, but like chatting to, you know, you about it's the next best thing, you know, it's really sick. So I think a lot of it was really just like my passion and my interest. And that's what really sparked my joy. And, you know, I was lucky enough to be able to build a career around that, you know, which is hard to do. It's hard to get paid to do something you love, you know, like not everyone has the ability and the privilege to do that. So I'm super, super lucky. And And yeah, now like I've just like kind of gone down this whole path of yeah, in a weird way, like thinking about like education. So I work now, you know, supporting like communities and schools, especially, you know, like in rural Australia and places like this that may not have, yeah, all these incredible, like, you know, places out here. Like, how do you help these communities talk about science as well? You know, and how do you help them like get jobs that they want to get? How do you help them, you know, just, you know, have a platform to talk about the science they want to talk about, you know? And I feel like there's this real, it's this privilege that we get to sit down and have these kind of chats. And I want everyone to have the ability, if they wanted, to have these chats as well. So yeah, it's kind of funny. Like I don't miss the grueling hours in the lab of my, you know, of being an academic and that kind of stuff. But these chats are really sweet. Like I really love the way that, as humans, like we want to take the time to sit down and ask what the fuck's going on.
Yeah,
you know?
we're curious.
Yeah.
And what's always driven me towards science personally, and often I hear a lot of scientists give a different answer, but I just want to know for the pure sake of knowledge.
Yeah.
And this might sound a bit selfish and like not good for the world. But I promise I don't think I'm a bad person. But I'm usually less interested in science that has a practical purpose for the world. And I really understand its place, and all power to it, you know. And that's things like medicine, environmental science, all these things. For me as an individual, and I'm not saying everyone's like this, but for me as an individual, I just love knowledge for the pure sake of it. Yeah. And so when I look at sort of like us going to the moon, it's like we did that for the story of it, because we're storytellers. Like, how crazy is that we just did that? And it's like, people might intellectualize why it wasn't worth it or whatever, but it's like, I don't care, because that was awesome and we did it because why not? And I see this pursuit of, so I'm not trying to like undermine astrobiology, but I see this sort of similarity of like, let's not think about the economics of it or the politics of it, or just not even try and overthink it of like, how do we justify it? It's like, we're here, we've got questions and we want them answered. And the fact is, in my mind, like finding life on another planet is one of the most philosophically profound like discoveries ever. Yeah. And that in itself is justifiable, because like what we talked about, those things like art and empathy for other animals that on the surface don't quite make sense, and don't quite make sense in an evolutionary or biological sense, yet we have them. And I'm sure most of us would agree life's not worth living without it. So why not just like, don't think about it too much, and just
totally, and it's this weird thing.
Find life.
And I couldn't agree more. And I feel like there's this, and it's kind of this weird paradox in the field of astrobiology, is that when you sit down, you know, you have these chats and you think about like how beautifully, like statistically impossibly rare it is that evolution can drive an entity to want to think about its place in the universe. You know, that is so special and so unique. And like the fact that we want to sit here and just like do science just for the science sake of it, like that is so insane. Like that is so amazing. But then like every single astrobiologist, I don't know if any of them ever listen to this, will be like, half their job is trying to get funding. And try and justify their work in an economic system. And be like, oh, I'm, you know, trying to figure out what's the best solvent for DNA to work in, but also like you could use these new products for cleaning, you know, like listen, that's like the grand stuff like we're writing, right? It's like we're trying to find a way to justify ourselves to make money so that, you know, people will give us money to keep trying to figure out how the fuck we all got here, which to me, like that is the most amazing thing. So I feel like astrobiology opens up your eyes to how incredible these questions are, and how like we are probably the only people in our galaxy probably asking these questions. But then we have to like go to work and be like, please give us an extra like, you know, few dollars so we can pay for the money to like ask the like most statistically amazing question in the whole wide world.
I agree.
That kind of sucks. Yeah.
Yeah. I think we'll wrap it up soon, but I wanted to, it reminded me of something, and I feel like we have to bring it up in this about the Mars rock. But the way I want to tie it in is about this sort of perspective of science and understanding our place in the universe. And so I told you this the other day when we got a coffee or some lunch I remember the day that NASA came out with this news that they'd found this rock, Chevea Falls, anyway, something like that. And it shows they couldn't find another explanation after a year of how these sort of leopard spots got there. And it appears to be sort of like fossilized microbes. They want to find another explanation. They couldn't. And the way I'm going to link this into what we were just saying is that I only learnt about this like almost the next day, because when I opened my phone, when I went online, it was all about like Charlie Kirk's death.
Yeah.
And so while that was a big moment for the world, in my eyes, I was like, no, this is way fucking bigger. Like life on another planet, life on Mars, and then I'm going through some of my favorite science communicators who are rightfully so more skeptical than I am, and kind of being really open to this idea of saying like, no, this is real. Like there might be life on another planet.
Oh, yeah.
I mean, what was your reaction when you first read that? Was it like I kind of suspected it, or like whoa, really?
Yeah. I was really excited, honestly, when I saw it. I thought it was cool. And I think that I've been lucky enough to work with some of the scientists that have worked on that paper, but also like worked on other kind of papers like that. And especially it was a similar thing. They found a chemical in the atmosphere of Venus where they were just like, on Earth, we only see this chemical when life's around producing it. Like there's nothing that produces it in these quantities. Could this be on Venus, And I think both from working with those scientists, and we like co-authored a few papers around that, plus like chatting with people who've, worked on these leopard spot stuff, the lengths scientists, and those scientists in particular, go to prove themselves wrong is incredible, And I think that that's like the real, like to me, like the real crux of science. And the real thing that makes science good is that you'll see something and you get a hypothesis. And I'm sure the first time they saw those leopard spots, they're like, we always see these spots when there's microbes present that form these like calcium sulfide, like the way the crystals formed. You only see that when there's microbes involved on Earth. Maybe that's it. And that would, I'm sure they would have been excited. They would have been bloody cheering, But like I know, and you see it in the paper, they spent so much time trying to prove themselves wrong. And they're like, here are all the other things that it could have happened. And this is why it might have happened on Mars. And like, what is this? And was it that? And they are like, almost like their own biggest self-critics fighting so hard to make it not that.
Yeah.
And they excluded and they extinguished all those options, and only then they put that paper out, And I think it's a testament to science. Not saying that that's life at all, and they're very it's very speculative. They're very just like, we don't know. We need to get this sample back. The interesting thing, and bringing it back to politics, is that like they found this incredible sample. The only way to know, not even for sure, but the way to get really good evidence is to take that sample and bring it back to Earth, and to get it into a lab and to be able to cut it up and be able to look at it under a microscope. But there's a lot of cuts to funding in science at the moment. A lot of the NASA programs for the rovers to bring those samples back, from my understanding, have been cut, or, the funding's just been pushed back massively,
Yeah.
So I think that there are very real world human, issues that are really getting in the way of, literally figuring out if there's life on another planet. And I think, I'm not saying that that's better or worse, but it's interesting. Like, it's all connected. Like, science is political, and we're living in a world where that happens. And I think that to say that it's not like that, you're just putting your head in the sand. Yeah,
totally. Especially something that could fundamentally change our whole perspective of the universe. I mean, the first thing that always comes to mind for me is like the religious impacts life on another planet would have. Because it's like, well, maybe we're not so special. I mean, Darwinian evolution was a similar thing, which said like, we're actually not so special compared to everything else on this planet. Like we can explain ourselves, that we all came from the same loin, right? Yeah, but to find on another planet suggests like, okay, so even like the event of life's synthesis, its origin, may not even be as rare as some may have thought. And like, of course, we talked about this, but it's, it opens up the potential that maybe simple microbial life, that slime you're talking about, or the mat, or moss, or whatever, right? It could be relatively quite abundant. I mean, depends how you define the term relative, but in my eyes, if there's more than one in a galaxy, I'm like stoked.
To be like the closest planet to Earth, if that also is like, right? It's like, that's like literally the closest place we've looked, and there's something going on there. Like, it really opens up the possibility.
That's, to me, is insane. And and so, again, we don't know. I'm just curious, and you don't have to believe in either answer with 100% certainty. You could be like, oh, I'm a bit split between them or whatever. But do you think it's more likely that assuming that there was life on Mars, do we share an origin with them, or have we both evolved or sort of originated independently from each other?
Honestly, I don't know. It's an interesting question. I think that something I wasn't aware of was like how much material is exchanged between Earth and Mars. Like there are like a large number of like very well documented meteorites of material that was literally just like something like a comet or a meteorite hit into Mars, sprayed a whole bunch of Martian rock out into space, and that then landed on Earth. And like, to me, like, that's crazy. Like the chance of like literally spraying off some rocks and then them hitting Earth that's also spinning around the sun. Like, there must have been so much rock spraying in space, or it's so lucky it landed here. But it happened a whole bunch of times, right? And there's a really famous example of that, and I think it's called like the Allen Hill meteorite.
Was this the one in the 90s?
Yeah, and it landed, I think, Antarctica.
Right.
And it was basically a rock they found that ended up being a meteorite that they ended up cutting open, looking at it, and they were like, yep, this is definitely a rock that formed on Mars. And how they knew that, I don't know, but like there was a whole bunch of really good science, they figured it out. And when they were looking at it under the microscope, they saw lots of little wiggly blobs that looked a lot like fossilized microbes. And they were like, this is it. This is like the evidence of this idea of panspermia, or about life being seeded on Earth from Mars, because like we've got a rock from Mars that has like microbes in it, right? It was this huge debate, like huge scientific excitement around it. End of the day, and this is kind of widely accepted, they found that those wiggles were actually a artifact of the microscope technique. They're actually put there when they were like cutting the rock up and making it into like the slides to look under the microscope to like, it's called like scanning electron microscope, the way they were like looking at the rock, little bits of like dust and crap were like stuck to it basically, that ended up, like microscopic.
That's a bummer.
Yeah, totally, like really. And I think it kind of demonstrated the level of like scientific integrity, right? When scientists were able to go out there and say, no, we were wrong, right? Like, and the techniques we used weren't perfect, and there was, basically dust on the lens, a better word of it, that proved it wrong. But despite that, like, there's still a whole bunch of rocks being chucked from Mars to Earth and from Earth to Mars all the time. So like, I guess if you ask me if as like a betting, like if you're like, I'll place a bet statistically, what do you think could be from Earth? But again, like, we won't know until we can get it out and genetically, like the dream would be, like these leopard spots, from my understanding, there's no genetic material preserved in there. It's what they call like a biomarker or a biosignature. So it's like, it's just a very simple like a mineral. It's like calcium sulfate. So it's a very simple mineral that like is really boring, but it only forms in these like kind of like little spotty ring-like structures when there's microbes there making it happen, right? But like it's not like they found evidence of DNA or found evidence of life that's growing there, which would then, if they did find that, would be the way that we could go take that. We could genetically, examine it. We could sequence that. We could grow that life in the lab. We could actually like really figure out, was this life from Earth or not? If it's just these like, leopard spots and that's it, that's really sick. Like, let's go and study it. But without genetic information, we'll never be able to tell.
Or is it possible that we actually came from Mars?
Dude, we could be Martians. It looks like we're nearly from Mars.
We are.
Right? Like, with some couple of rocks behind us.
Well, context, we're in Alice Springs, and I did the Larapinta, famous walk here, the Larapinta walk, and not the whole thing, I need to clarify that a part of it. And I was told that they do film things here, like maybe it even was the film The Martian, part of it. Anyway, that like a lot of films come here to film scenes on Mars because you can look at the rocks; they resemble Mars, except for all of the buffel grass. I don't think Mars has buffel grass.
No, I bloody hope not. Yeah,
but which is a very invasive species here. But it's an interesting question. I think like Mars will always, in my eyes, for it to have life is remarkable because, like what you said, it's literally the closest planet to us. In the universe, well, right. But of course, something has to be. But for that to have life is like, wow, that that is a huge what do you say, like indicator of like it either. And correct me if I'm wrong, but it kind of points to two possibilities. Is that either like life maybe springs up more frequently than maybe we first anticipated, or that life traveled between the planets, which I think is also just like as crazy.
It's super cool.
And so either way, like it's
either way, it'll be amazing. And I feel that and maybe this is a bit controversial, and I say this with a lot of caveats, but I would never want to do this, but I personally believe like humans should start a colony on Mars. Like this is and I think that
I actually agree.
Yeah. And I feel like I would never choose to do that. And I was invited to do some of the like Mars analog programs. So you go to, this was in Utah, but there's ones now up in Ladakh, so up like north of India, and there's one actually in South Australia setting up in Hawaii, and they're like, let's experience what it's like to be on Mars and like train you up. And like, I would hate that. Like, I love living on Earth. I love like having a beer and be able to breathe the air around me and all those kind of things. But I say that because I think that like life is unique in our galaxy on Earth. Like humans, like as much as like I think we're full of ego and we're arrogant and we think we're top shit when we're like really not. But also we kind of are. Like the fact that we can create art and cry over stepping on a snail and all the beautiful things that
music can make us cry.
Music, you know, like
makes me cry.
Yeah, like there's such like unique things we do. I believe the biggest tragedy would be if a meteorite came and wiped us out, which is probably like beyond nuclear warfare is like our biggest threat. And probably, statistically, we've had, life-ending extinction events in the past, and it's only a matter of time until it happens again, right? And I think that, supporting humans' growth throughout the solar system, I think is our best safeguard to stop that from happening.
Yeah.
Doesn't mean that I believe in a lot of the colonial expansion on Mars. The mindset that we have of it, I think, is really poor. I think that means we shouldn't be neglecting the suffering and the issues that are happening here on Earth. And I don't want anyone to be adding you in the comments about, like Elon Musk and all this kind of stuff. I feel like the way we're going about it maybe has to change. Yeah. But I think that like humans are special, and I feel that we should really safeguard humanity, and I think that's one way to do it.
Like a backup drive.
Mate, dude, honestly, like you got to back up your hard drive every now and then. Like.
Exactly. I mean, I totally agree. And I think you're spot on about the mindset of it, because people are getting very Did you want another drink?
Dude, yeah, go on.
Yeah, let's.
Yeah.
People get very sort of tied up with Elon Musk and, you know, whatever, like he's a controversial figure and whatnot. But I think the way I see it is somewhat similar, and like, you know, we do need to protect ourselves from the possibility of meteorite, but even, you know, like even a nuclear winter or, you know, like threats against ourselves. But I think it's crucial that, as you said, it's not like let's move to Mars and forget about Earth and fuck up Earth. It's not like we move there and then give up all responsibility of looking after it. It's not like that. It's, you know, it's try and make this the most beautiful home for us as well. But, you know, there's also like, there's potentials for overpopulation or just, you know, like for scientific investigation. Like to me, it seems like the obvious next step for humanity is to go, interplanetary. In our progression, I'm just like,
totally,
right? You know, and it's a shame that like people feel reluctant to it because of just say the politics of it or the idea of like abandoning.
Well, Earth. And I think there's like this idea of like abandoning Earth or like I just finished watching Don't Look Up again.
I literally watched that like a month ago for the first time.
Great, like,
it's really it's frustrating watch, but it was like awfully relatable.
Totally, yeah. And I think the idea of interplanetary exploration being fueled by like billionaires wanting a backup plan, like fuck that, like you know, I think that's real, like you know, that's not it, but. And I think, you know, like we're getting into politics, which is natural and that's scientific, but I feel that
well, question everything. That's what a scientist does. Even politics, you question everything.
Yeah, totally. And I feel that they're like colonization has been a force of, you know, massive disruption here in Australia and around the world, you know? And I think when people talk about colonizing space, it's like, what, like, have we learned nothing from the way that, you know, certain countries and certain people in history viewed the whole world as this thing that they can just go and take over and have no disregard for the people living there or of the rich, you know, knowledge and science and history that is there. And I think that if we carry that mindset into the way that we view space, like I think that's really, really crappy, you know? But it was really special. I just spent a bit of time over in Hawaii, which was really sick. And I was,
true.
Yeah. And it was really cool. I spent, a whole bunch of time with these amazing, like, First Nations, like Native Hawaiian people and like, you know, and, non-First Nations people there that were really into revitalizing this concept of voyaging and the way that Native Hawaiian people would like it's just the most insane astronomy and navigation and maths and engineering. They build these like huge and like Moana, like everyone's, you know, like sitting there, but they build these like canoes and would just like sail out into the open ocean, you know, and not be able to see land. And really just by having such amazing exact knowledge of stars and, you know, like life-sustaining systems, like how do you bring water? How do you bring food? Like all this like crazy stuff. They explored, amazing parts of, you know, the world, and like, you know, all of the Pacific Islands were like done through this very intentional, very scientific process that they did, you know. And I think that like on one hand that is, you know, like colonial, but it was done, you know, also with this real sense of exploration and respect. Just the way that, you know, like I was there for like 10 days or whatever, you know, I don't know, I'm just like scraping the surface, but the way people...
You got a little like view of it,
I was like, man, this is like sick. And I think that is this idea of, you know, exploration and, you know, exploring new frontiers, I think has been co-opted by this idea of colonialism as a negative thing. But I think it's really beautiful. And I think we should do it with respect of the space that we're looking into. I don't know. I think it's cool shit.
May I just add that, like, I think because the word colonial has been very tied in with the word imperial. So maybe like it's important to distinguish those because like colonial, like in its essence is just to set up a colony somewhere else. So like, if we go to Mars, like that is colonizing Mars, no matter how you look at it. But imperializing is sort of that aspect of doing it for the sake of spreading your values and your genes, and domination, right? And so, I think
totally.
It's hard to use the word because they've become synonymous when they are different. Yeah. But I think you're right. And I think that's a really cool point as well. And another, like, about what we were saying about natural human instincts and cultural things is our exploration, our explorativeness. Yeah. So, like, for context, our species is, modern humans, they say, is about 200,000 years old. And we came out of Africa. And at that time, there were other humans around the world. Yeah. And so there's something in, like, our genus, Homo, like, that made us just want to fucking move, like, and we explore. But, something about us as well. I think it took a couple of attempts for us, the Homo sapien, to leave Africa. I think the first attempt we failed, and we did it again, and we outcompeted the Neanderthals, the Denisovans, all these other human groups. But we went further, right? We actually have gone to every corner of the earth, and what you're talking about with, like, the Polynesians, like, and so just saying, like, Hawaii and the Maori, and just, I've always been so impressed by the length of, like, ocean expedition, because it's one thing to go over land, but we're not aquatic animals.
It's fucking terrifying.
It's terrifying. And here's a fact. Here's a fact I absolutely love. I learned this about a year ago. Is that if you people of Madagascar are not full African. In fact, the first humans to set foot in Madagascar came from Indonesia.
Whoa.
Yeah.
Yeah. That is crazy. People are so, like, they're
all the way from Indonesia, the first humans, and then Africans came later, and so you can actually see photos of people from Madagascar, and it's this beautiful, like, look to them, like, and they've done, like, genetic analysis, and they know, like, these people from Indonesia came all the way across, and they're this beautiful, like, cross, like, mix between the two. It's amazing.
It's like no disrespect to, people who love sailing, but, like, that must have sucked, dude. Like, being on, like, a canoe for, like, like, weeks, months, like the humans drive, and, like, these incredible, like, Indonesian explorers, and, like, these people that, like, explored all through Polynesia, like, the drive to explore and to, like, keep pushing those horizons in the face of, like, no fresh drinking water, like, no food.
Why?
Yeah. But, like, like, I feel like, I'm lazy. Like, I'm just like, I don't know if I would driven to that, but, like, there's these incredible, like, innovative, amazing people that were just driven to just, like, look over that next horizon, and I think that's really, like, they're the reason that, like, humanity, or maybe humanity is the reason why they did that, but, like, there's something in us that wants to just, like, explore and find out why, and, like, figure out, is there life on other planets, figure out what's over the horizon. And I think that's, like, I don't think we should devalue that, I don't think we should put that in the same box as imperialism, as you said, and be like this looking at it, so you mentioned this buffalo grass, like, there's this idea of invasive species, and this idea of coming to places and, like, totally messing up the environment, right? Like, there's this grass you see all on the hills here, and this is such a big old tangent, but, like, from my understanding, was brought here when the British cattle drivers, like, they had all these cows here. There was all this dust going around. They wanted more grass the cows could eat, so they just kind of, like, put these seeds here. But what they didn't realize is that the buffalo, it burns really hot when there's a bushfire, but it comes back really quickly. So for, like, thousands of years, tens of thousands of years, like, local indigenous people like Aranda here in Alice Springs and all over Australia were using fire to help manage the ecology. And before that, it was this very complex system of fire. And you bring in this plant that burns differently, and it basically burns hotter, kills everything else around it, and then bounces back quickly, and it kills all the animals, it kills all the plants, and it's, like, destroying the environment. It's destroying the local like culture, because so much culture is tied with the animals and the plants and what's going on. And it's this huge issue just because someone came in, they didn't understand the system. They didn't understand this rich, scientific process that was happening here with cultural burning. And, like if we bring buffalo grass equivalent to Mars, that would fucking suck. Like that's what I'm saying. Like, like we have to tread carefully. We have to go in with such respect for the system, the environment, the context that we're going into as we're exploring, the galaxy. But I don't think that should stop us. I think we should have that awareness and that respect and tread lightly into the void.
I totally agree. I think, the respect is paramount, and we should never lose sight of it.
Yeah, and that's a human thing, right? Like, you said before, empathy, respect, like, so many species don't have that. Sorry, this is going on such a tangent. But
no, I love tangents.
Have you seen like no disrespect to killer whales, but they have no fucking respect. Like they play with their food. They will like grab a baby seal and just like
cats are similar,
dude. Yeah, like throw them around in the air and just like fuck them off. Like they don't give. Like they just have no interest in the respect for human life, right? Like,
but the funny thing is, I have respect for them not having respect in a weird way. I kind of see it. I'm like, you're fucking badass. Like, that's cool.
I can't see that, but only because I'm personally terrified, right? Like, that I feel that. But I feel like that, like we could have been killer whales. Like, humans could have evolved to just being like, fuck anything else that exists. Like, let's just stamp our enjoyment and our pleasure and our need to reproduce on the world, and like who gives a who cares about anything else? But we don't. We care about that. We don't play with our food. We don't, we would try and reduce the amount of suffering, even though we still cause a whole bunch of it around the world. And we're really lucky that happened. And I think that we shouldn't, as we go out into the universe, like that human ethos of respect and empathy, we should apply that to all things elsewhere, because that's what makes us cool.
Yeah. I agree. Well,
I covered a whole bunch of stuff, dude.
I know. That's my favorite way of doing it. I think like almost what you were saying about your time as a researcher, what always scared me off about doing research was that, I guess like back in the day, you look at like scientists historically, and they were polymaths. They were like mathematicians, but then they were also like biologists and physicists, and studied the stars, and then did painting in their spare time. And, even someone like Newton, he was like, just say a classical physicist, but his expertise in physics went from gravity to optics, a range of other stuff.
Dude,
But what scares me about modern research is that, and this is why science is so effective, but as our knowledge has grown, it becomes increasingly more specialist. And so I got really scared of like, I always wanted to do like marine biology because I love the ocean.
Yeah.
And then I was like, just thinking, I had a bit of an existential moment of like, am I just going to be spending 20 years studying how like clownfish reproduce between the tropics of Capricorn and Cancer? And then I was just like, fuck.
Mate, like you'll literally be like studying the one pheromone that one clownfish releases in one reef. Like science is so hyper specialized, and it needs to be, we've done all the big fun shit now.
I know.
Doubling down on all this stuff.
It's sad,
but I think that's still like, astrobiology is really cool because like literally like it's one of the newest fields in science. And there's so much, and I kind of did this when I was like, I would always give talks to like undergraduates when I was at uni. Like I'd be like, a PhD student coming into like the third year chemistry or geology class and be like, oh, hey, like thinking about astrobiology as like, a research topic or to do your honors research in. And the way I would sell it, and I feel like this is kind of cool, is that it's got like the lowest hanging fruit in science. Like Newton could come along and like, obviously genius, like amazing, researcher, but also like no one had studied, the physics of motion before and of gravity and like Newton's third laws and that kind of stuff. You can come in and make these big, like wide sweeping claims because no one's done it before in that context.
Yeah, I think that's a really cool way of
looking at it. But then, in astrobiology, it's like, what is life? It was only like a decade or two ago, people actually like came up with an idea of that.
Yeah.
And like put a stamp and it's like, oh, this is what we think. Like there's like so much new stuff to explore in astrobiology, and there's so much low-hanging academic fruit because literally no one's had the time, funding, or prior research to actually ask these questions like, why does life need DNA?
Yeah.
Why does life need polymers to string information together? All this kind of stuff. So it's those big questions are still there. You just got to like look in weird ways to find it.
And they often have ripple-on effects in that like, and I'm sure you may have experienced this in trying to find grants and justify research, is that the benefit to a scientific pursuit might not be obvious before you've done it, right?
Yeah.
I had examples in my head before which have slipped my mind. But
I've got a call if you want.
Yeah, please.
So I love using this one a lot because the research I was doing, like, origin of life, how did life form? I was really trying to figure out if life could have formed in a hot spring. That was my whole shtick. So I would like go to hot springs around the world and like understand the chemistry of them and stuff.
I hope not bathe. You wouldn't just sit in them and bathe.
Dude, sick. No, you could. Like, like you go and like collect your samples during the day, and then in the afternoon,
in your board shorts,
dude. Yeah.
With a snorkel.
Again, man, a crazy tangent is so a lot of these hot springs are like really acidic. Like heaps of like sulfuric acid, like sulfuric gases going around them. It's cool if you're a tourist and you're just visiting for a day, but if sulfur like eats into your pants, if you sit down on the ground like over a week, literally I was like walking up some stairs and like took a step up a stair and my pants just like ripped in two.
Wow.
And your shoes are falling apart, and like these places are actually like very corrosive and aggressive if you spend enough time in them.
Wow, okay.
But anyway, so studying hot springs, like weird place to study, and I was like, oh, like what's the value of this? And it turns out that, like, have you heard of like a PCR test? Like, when COVID was around, you would get your rat test, which is like a little up, little bit of plastic that would tell you what's going on. And there was also a test called a PCR test, which is where they would take a swab and they would look at the genetic material in that and be like, is there COVID, virus genetic material in this, sample you got? And the PCR process is a way of amplifying DNA or amplifying genetic material. So you could get a swab and there could be like a couple of hundred, a couple of thousand, DNA molecules on your body in that swab. And you can put it in there and you can take that and you can cycle it through a process of heating it up and cooling it down with a few bits of bacteria there or bits of, molecular support there, and you could create a couple billion bits of DNA.
Wow.
And then you have heaps of it and you can process it and figure out what's going on. The process of that and the bacteria or like the molecular process of doing that was discovered from studying bacteria in Yellowstone Hot Spring. And the dude that did that had no idea that, I'm sorry, I assume, was it a dude? Probably was a dude. What was his name? Anyway, the researcher who did that, checking myself, they were literally just like, oh, like, what's this weird bacteria that's going on? Like, scrape the side of a, hot spring wall. Looked at it like, oh, like, it kind of like can change in high temperature environments. It's really good for, growing in these high temperature hot springs. No idea of it. And much later, like, oh, wow, this is what we need to like replicate and amplified DNA was hidden in this hot spring material. So I'd always tell that when everyone's like, why are you like fucking around hot springs? Like,
And wow. But no, that's a perfect example.
Yeah. Anyway, that was a big old tangent.
No, but I love that. That's exactly like sort of what I meant is like, like I was saying, not that I actually really personally care about justifying pursuit of knowledge, but that is a good justification and that like, just do it because you never know what shit you're going to find on the other end.
Yeah. And I think that at the same time, the person who did that research, they weren't being like, I've got to find a way to justify this. They weren't searching for some like, money-making, bacteria. They just really loved hot springs. Yeah. And I feel that if you were forcing them to be like, you have to justify how much money you can make of each time you go to the hot spring and like scrape off your slime and analyze it, like they could have never have done that work and we never would have had the PCR test that we have today, So I feel like even though retrospectively we can be like, oh, damn, like that made us a lot of money. If we then enforce that on people doing current research, it's a massive inhibitor.
Yeah.
Yeah.
But that's a good point. And that this is what I love about scientists is that so often they kind of are doing what they love, like you hear their personal story and it's like, oh, they're a marine biologist, like because they've always loved the ocean, or you're a physicist, like I've just always loved science fiction and learning about like so often. I'm sure it's not the case with everyone, but I've seen like so many cases where they are driven by a love of what they do, and like this sort of childhood fascination, which is definitely something that drives what I do, and I think like it's really important we keep that. It's learning how do you become a mature human whilst keeping like all your childhood like qualities in that, and I think curiosity, open-mindedness, but those are obvious ones, but like what I think is so great is just like loving shit, like just being like, this is great. We often think like it's overreacting or whatever, but just to like be obsessed by stuff and just to love it, and don't rationalize that love, don't intellectualize it. Even if you're a scientist, like it doesn't matter. Like you love it and you just do it, and you just and that's the beauty of children, right?
Totally. Yeah. And I think no one like would want to do this otherwise. Like it takes a very special person to be like, I want to every year spend my entire year obsessing over one hot spring pool and like scraping it out and being there early in the morning and like spending countless weeks in the lab analyzing that. Like you wouldn't do that unless you loved that, right? Unless you had this like real morbid, like childish obsession with it,
Well, I mean, there's a lot of people who do work they don't love though.
Totally. Yeah.
So, I mean,
but I totally agree with that. But I think that a lot of scientists I see is, and maybe this is a benefit of like that grant system, you're always having to justify yourself, right? I think there's a lot of jobs, and like we've all worked jobs that have been like, we've all made, I don't know, done hospitality. You've been a waiter. I was washing dishes, at the local cafe. Like that sucks. You don't want to do that, but you're not like fighting for the opportunity to do that a lot of the times, right? It's like, okay, like I'll do this. I'm not passionate about it. I'm just doing it because I need to make money at the moment. Yeah. Where like every year that person who's collecting the slime from the hot spring, they're writing a letter being like, please give me more money. Like I need to do this, like if I can't go and scrape that slime and study it, like my life and science is going to be, at a loss because of that. Yeah. And, I think that's something unique about science. You have to always justify what you're doing. And I think that would weeds out a lot of people. Like if you're just doing it because it's a good job, you can make a lot of money doing shitty pharmaceutical research and making new drugs and other things, right?
Because unfortunately, it's not always like a good job in terms of a money business, which is a bit tragic. In that, some people, spend years of education, probably, potentially put that same amount of work into another field that does have a lot of money, but they don't because that's what they love.
Totally, yeah.
And I think we should. It's very admirable,
Oh man, and I think that's why we should like celebrate that like weird, childish, obsessive, passion that like I have, that you have, that like, we shouldn't downplay that. We should celebrate.
No, of course. And I think, and but as both of us being science communicators, like that's what our goal is, right? To just share the beauty of science. Because I guess sometimes like, I guess science really is a method. It's right? Like it's hard to define science, first of all, but what appears to be the commonality between all forms of science is their methodology, their approach to knowledge. And so when you get too caught up in the methodology and like just talking with scientists and even with you, like what's so great about you guys is you're really like strict on like what you consider to be knowledge and what you consider to be speculation, which is amazing and something I need to, be better at. But what I was going to say though is like when you get too caught up in that methodology, sometimes, and my experience is, it can take away that initial beauty and passion that you had about the topic. That was my experience at university. Like I've always been obsessed. Well, I've always loved evolution and life. I love learning about the universe, and to me, life is the strangest thing in the universe, and so why not? And then, I found myself caught up in the methodology of it more than the appreciation of it. And so I've drifted towards science communication for that reason. Is that sorry, those beers. Just to like stay in that lane of like passion and love.
Totally, yeah. And I think that like a common factor in that is that while you're kind of like, if you're in high school or in university and you're kind of grinding through the method of doing science, and like you might be like, oh, I love biology, or I love life, or I love, like planets and space, and then you have to do a whole bunch of maths to understand that. That really sucks. A lot of the times it's having a awesome teacher or an awesome professor,
so important,
someone who like they are the communicators, right? And they manage to like, I know like every single teacher I know that's like, inspired me, they managed to keep that passion alive. Like they're teaching like boring stats that like, like no shit on stats, but like they're teaching like something that's like very mundane from my perspective, but they love it because they're like, no, this is how we can understand life better. This is how we can literally like look into other stars in our universe, is from doing this really boring differential equation, and like they kind of like keep that passion alive, and like good on them. Like I for a number of reasons, but like I couldn't do that, right? Like I couldn't keep my passion for science couldn't sustain the the tough hours and the repetitiveness of lab work, and the fact that I'll probably have to like travel overseas and like get jobs doing things I don't want to do, and all this kind of stuff to kind of keep a career as like a research academic. Like I kind of found a different path, but people who keep on that path, I really admire them. It's really amazing.
Oh, me too. Total admiration, because it is for that reason, just like, it is for the betterment of humanity, and most of the time. Anyway. But and even like teachers, what you said, I just really related to that point you said about good teachers, because for me, I was always really obsessed with science, like as a child. And I loved learning, and I'd always ask my teachers questions, and they'd be like about like black holes, like in year 5, and they'd be like, "Oh, people are often very dismissive," and I found I lost my passion in high school because, and I don't want to blame anyone else. Like at the end of the day, it is sort of my reaction to it, but I felt I wasn't in a system that supported my love for science, and it wasn't until I had good teachers. I had one really good teacher. I actually had a crush on her, but that was definitely like 75% of the reason. But she was also a great teacher. And then she left, and then she was replaced by this other guy who was also a great teacher. And so I realized it wasn't just no. He was just great, full stop. And like I realized, the power of a great teacher was, It was actually almost a bad thing for me, because these were my biology teachers, and I ended up doing biology at university when I always wanted to do physics. And they were such good teachers. They prevented me from going to like my preferred area of science. But nonetheless, I think that's small in the grand scale of how important teachers are. And I think I've always thought, we should wrap this up soon, but I was going to say, like, I've loved this. Honestly, I'd keep talking, but I know I have to go to a dinner after this as well. I think the world needs to reframe our perspective of teachers. I think even just take the word teacher. We've said it so many times, it's lost its meaning. Like, oh, he's a teacher, you're a teacher, she's a teacher, whatever. But just like, for me, this might sound a bit like crazy, but just stay with me. It's like, you're not a teacher, you're a teacher. You teach people, and that is a huge responsibility. And I think we forget that. You know, anyone can sign up to become a teacher.
Yeah.
You kind of just got to do the work, because unfortunately, like, we're in need of so many teachers. But that is massive. People might say lawyers or doctors are the most important people in society, but bullshit. Like, there's no lawyers or doctors without teachers. Teachers are the number one most important role in society, and that is my opinion. And I'm baffled by how little respect we have for the profession, and that, you know, people go on about salaries. Whatever. Like, money's one thing. It's the way we like perceive that job as a teacher.
Totally.
They'll go on about salaries, or like having to deal with like emotional children. I totally understand that. But I just think we need to change our perspective of teachers as not just like, oh, you're a teacher, but like almost like we need to glorify it to what it should be. It's you know, you see other cultures, and like the teachers were like pedestaled as like the wise people, like, oh, they're the teachers, like, you know, they you know, only very important special people get to the place, because they have such an important role of spreading their knowledge.
Dude, I couldn't agree more, and it's amazing. In my current job, like, I work with a lot of teachers, and I'm just like blown away by how like amazingly like just like their passion and their like the level of intelligence you need to like manage a classroom, like behaviorally, you know, but also just like the like understanding a concept well enough to like explain it. Like, I'm just amazed by what teachers, like, what a good teacher has to do, you know, to be a good teacher. And I think in the way that we value in a society, I saw that heaps when I was doing this PhD, and like, you know, talking to people about like, what do you do for a postdoc? What do you do after your PhD? And a lot of people would like talk about, oh, and like, if everything else fails, I might go into teaching. And I'll kind of like see it as this like backup plan.
Yeah.
And I've always just been baffled by that, because like, to me, like, I would love to like one day be a teacher, but honestly, it's weird. Like, I don't feel like I'm ready for that yet. Like, I feel like there's such an amazing responsibility, and like your offering to the world is so huge as a teacher. And like, I want to like, if I do that, I want to like go in there and like give it my best. I feel like I'm still learning about the world, you know? And I think that I don't see it as this thing that's like, I was really upset when people would say it's a backup plan, because I see it's almost the pinnacle, you know? It's like you are ready to like share that knowledge with other people, you know?
And your impact is enormous. Like, we totally like...
The burden and the responsibility as a teacher.
Yeah, I'm always disappointed by like how we just don't respect that enough.
Yeah.
But I guess, and like how, because like I've done teaching as well, and it is tough. And so for me personally, I also, you know, I've tried to extend what it means to be a teacher to not just schools, because we also forget like teaching doesn't have to occur within an institutional educational environment, but like, you know, parents are teachers, friends are teachers, lovers are teachers. Like, who are your teachers is more than a role that we just call a teacher, right? And so that's why, as you know, science communicators, we are teachers, you know, and don't underestimate that. That's you know, just I could go on, but I think it's
Mate,
it's a beautiful space.
We gotta like,
no, but I've absolutely fucking loved this chat.
Yeah, it's been
been great.
Yeah, I honestly like so probably, I don't know, this is not probably the best, but like so many times I've been like forgetting we're even in a podcast, and it's just been amazing just like having a chat. And I feel that like I think this is the reason I do what I do, and it's probably similar for you, is like I want people to have these kind of chats with people, you know? I want like I want to encourage or like spark ideas or give people just kind of like little insights that they can just like sit down with a mate after work or after school, or like go for a walk and just like, what is life? Like, who are we? Like, what makes humans so special? Like, whatever it is, like, I really want people to have these kind of conversations, you know? Yeah. I think it's been really, really exciting to like dive into all this stuff with you. It's been incredible.
I'm actually really keen to do this again. I think maybe next time I'm in Alice Springs.
Dude, I love that. Yeah.
Let's do this again.
Yeah, that'd be incredible.
because no, this has been great. And it's nice to talk about science on this podcast as well. Dude, absolute pleasure.
Yeah, definitely, mate.
Shall we cheers?
I'm actually literally all out of beer.
That's all right. You can't cheers on an empty bottle.
Crack a new one. So let's.
Let's. All right.
Which is next time we do
thank
this.
you.
Yeah, thanks, Zach. Yeah, awesome.
Fuck yeah. All right. Awesome. Dude, that was so